In section 6, we're going to talk about the law of cosine. So as we saw in the previous section, law of sines only works for angle-side angle and side-side angle cases. However, we'll sometimes have cases such as side-side-side or side-angle-side. And for these, we use the law of cosine. So in a triangle ABC, just like in the law of cosines, we have angles A, B, C, and their corresponding sides A, B, and C. So with the law of cosines, we have three different relationships that hold. A squared is equal to B squared plus C squared minus 2BC times the cosine of A. B squared is equal to A squared plus C squared minus 2AC times the cosine of B. And C squared equals A squared plus B squared minus 2AB times the cosine of C. So we can use any of these relationships to help us solve for a missing side or missing angle using the law of cosine. So our first case is the side angle side. We're given information of two sides and the included angle. So we want to solve the triangle ABC, given angle B is 51 degrees, side C is 23, and side A is 7. So let's go ahead and identify that information. So angle B is 51, side C is 23, and side A is 7. So given this information, we can actually solve for side B using the law of cosines. So we're going to use the B squared equals A squared plus C squared minus 2AC times cosine of B. If we go ahead and plug in what we know, we get B squared equals 7 squared plus 23 squared minus 2 times 7 times 23 times the cosine of 51. And we want to simplify as much as possible without multiplying by the cosine of 51. So 7 squared is 49. 23 squared is 529. And then 2 times 7 times 23 is 322 times the cosine of 51. So 49 plus 529, we're going to get 578 minus 322 cosine of 51. So here's where we're going to go ahead and round. So 578 minus 322 times the cosine of 51. And we're going to get B squared is about 375.36. So in order to get B, we're going to take the square root. And B is going to be about 19.37. So now we have all three sides and an angle. And instead of continuing to use the law of cosines to find our other two sides, we're now going to use the law of sines. So we're going to set up the law of sines. So sine of A over side A, which is 7, equals sine of 51 over side B, which we just found to be 19.37, equals sine of C over 23. So we're going to use this to find angles A and C. So we actually only have to use the law of sines once to find either angle A or angle C, and then we're just going to use the triangle sum theorem to find the other angle. So I'm going to go ahead and solve for angle A. So sine of A over 7 equals sine of 51 over 19.37. Multiply both sides by 7. We get sine of A equals 7 times the sine of 51 over 19.37 taking the sine inverse of both sides. And we are going to get that angle A equals 16.31 degrees. And now all we have to do is find angle C. So we're going to do 180 minus 16.31 minus our 51 degree angle that we're given, and angle C is going to be 112.69 degrees. It would have been a lot more work if we had used the law of cosines to solve for these two angles. It actually works out a lot nicer if we use the law of sines and then the triangle sum theorem. We're going to do one more example, the second case when we're given all three side measures. So we know that side A is 10, side B is 15, and side C is 22. So when we're given all three sides, we have to pick which angle we're going to solve for. And it doesn't really matter. I'm just going to go ahead and solve for angle A. So we're going to use the formula A squared equals B squared plus C squared minus 2B times the cosine of A. We'll plug in A, B, and C. So 10 squared equals 15 squared plus 22 squared minus 2 times 15 times 22 times the cosine of A. So we get 100 equals 225 plus 484 minus 660 times the cosine of A. So 100 equals 709 minus 660 times the cosine of A. So we're going to subtract 709. We get negative 609 equals negative 660 times the cosine of A divided by negative 660. We get cosine of A equals, and we're going to leave it as a fraction so that our answer is exact as possible. So we get negative divided by negative a positive, so we get 609 over 660. And then to solve for angle A, we take the cosine inverse of both sides. And we get that angle A equals 22.67 degrees. So just like in our previous example, now that we know an angle, we can set up the law of sines. So we have sine of 22.67 over 10 equals sine of B over 15 equals sine of C over 22. Just like our previous example, we'll use the law of sines once to find an angle, and then we'll use the triangle sum theorem. So I'm going to go ahead and I'm going to solve for angle B first. So sine of 22.67 over 10 equals sine of B over 15. Multiply both sides by 15. get the sine of b equals 15 times the sine of 22.67 over 10. Take the sine inverse of both sides. And we get that angle B equals 35.32 degrees. And now we just have to find angle C by doing 180 minus 22.67 minus 35.32, and we get 122.01 degrees. Now, based on which angle you solved for first at the very beginning, your answers may not match up exact with the decimal places because a lot of rounding has occurred to finally get angle C. So your decimal places, depending on which angle you choose to solve for first in a side, side, side case, may end up a little bit off, but they shouldn't be that drastic of a difference in decimal place as long as you wait to round until the very end.